Okay, so here we have a column of difference scores. So what we're going to do, because people are paired together, or the dogs too, are paired together, then we can subtract by the pairs, okay? And so, excuse me, I had a score of 10, and Bobby had a score of 9, and so we did 10 minus 9 equals 1. Now, you could subtract the other way. We could do 9 minus 10. You just want to keep it consistent how you do it. And you also want to remember how you did it, because that makes a difference in the hypothesis that you make for your research hypothesis, okay? So if I do 10 minus 9, I get a positive number, but if I did 9 minus 10, I would get a negative number. So it makes a difference. And if you switch the way you subtract, your sign in your research hypothesis will also switch. If you have a less than or a greater than. If you don't have a not equal to, then it doesn't matter, but when you're interpreting the results, it will matter. So the thing is, you can subtract either couples and solo counseling minus couples only, or you do couples only minus couples and solo counseling, but you need to know which way you did it, okay? And you use that information when you're making your hypothesis. So we have 10 minus 9, that's 1. So notice if we do a bigger number minus a smaller number, we get a positive number. And then the second people were my roommates, and so we have 7 minus 6, that's 1. And then remember we had our dogs. So we have 3 minus 15 equals negative 12. So notice if you have a smaller number minus a bigger number, you get a negative number. And then you guys, you and your significant other or your dream significant other is equal to each other. So we have 10 minus 10, that equals 0. So if they're equal to each other, you'll get a value of 0. So a bigger number minus a smaller number, you get a positive number. A small number minus a big number, you get a negative number. And if they're equal to each other, you get 0. And this is helpful to know when you're creating your hypothesis. So if you typically get negative numbers, that means your second number was generally higher than the first number. If you typically get a number that's positive, that means that generally the first number was bigger than the second number. And if you get a number around 0, that means that generally they were equal to each other. So when we do a dependent t-test, we get a column of different scores, and from that column of different scores, then we find the mean. So we just add those numbers of different scores up. We ignore the other two columns after we get the different scores. We add those up, so we add 1 plus 1 plus negative 12 plus 0, and then we divide by 4 because that's the sample size. And then we also get one standard deviation of the different scores. Okay, and so just like you did earlier on in the course, you get the standard deviation of this. So you get the sum of squares, and then you divide it by 3. And then you just do the t-test just like a one sample t-test. So you do the sample mean of different scores minus your hypothesized, or the mean from the null, which will be 0, and divide that by the standard deviation of just different scores, divided by the square root of your n. So it's just like a one sample after you get the different scores. So if you mix them up a little bit like I just did, it doesn't matter. It doesn't matter that now Jim's with Sophie or Lorna's with Matt, because they're not really paired together anymore. The way the data is doesn't mean that they're paired together. Okay? So what you're going to do is you're going to have a mean for counseling, you're going to have a mean for no counseling, you're going to have a standard deviation for counseling, and a standard deviation for no counseling. And then we're going to compare the sample means. You don't want to do a different score when they're independent, okay? Because I could put Jim with Sophie, but I could also put Jim with Matt, or Jim with Lars, and Jim with Sam. It doesn't matter. Like, how it's set up doesn't mean that they're paired together, and you shouldn't do a different score. Because these people don't know each other, therefore they're what's called independents. They're independent of each other. So you add up the scores for Jim, Lorna, Chunji, and Ryan. You find their mean. From that, you divide whatever total you got by 4, and then you do the same thing for the no counseling. You add up the scores for Sophie, Matt, Lars, and Sam, divide by 4, and get a mean for them. Then you also get the standard deviation for the counseling and people, and the standard deviation for the no counseling. Okay? And so if you mix up the data when it's an independent t-test, as long as they're in the same column, it doesn't really matter. But it does matter for a dependent t-test.